Hello again. So this is a similar kind of a question. It's a binomial expansion question, but they're only asking for this one thing. Find this coefficient. So you could write out this whole thing, but like that's going to take a long time. It's still the 11th power. So instead we want to kind of use the patterns we recognized before to do this without having to write out the whole thing. So every term of the expansion has three pieces. That's a very not horizontal line. It has a coefficient, it has a binomial coefficient, it has a power of this first thing, 3x, and it has a power of the second thing, which is 4. So I actually know right away that the power here is going to be 4 because it says x to the 4th. Oop. Yeah, so the coefficient, I don't know what that is yet. It's going to be 11 choose something. The power here is going to be 4 because it's asking for x to the 4th. Which means the power here has to be 7 because these two powers always add up to 11. And we saw that the number here always matches this number. So boom, I got this coefficient. The thing I'm raising to the 4th power is 3x. The thing I'm raising to the 7th power is 4. So really I have 11 choose 7 times 3x to the 4th is 81 x to the 4th. And 4 to the 7th is a number that nobody knows off the top of their head. It's 2 to the 14th. It's 16,384. So you can see the only variable left in here is x to the 4th. So I just got to combine all the numbers in front of it and see what I get. So you can use your calculator to find 11 choose 7. Or you could use the formula, but since you get to use your calculator, I recommend doing that. It's 330. Times 81 times 16,384 x to the 4th. 330 times 81 times 16,384 is a god awful big number. 437,944,320 x to the 4th. So that's like a very large number, and I would never want to try and figure that out. I would never want to try and get all the terms of this expansion. I would never want to try and get all these terms and then just pick out the one with x to the 4th. This is a much faster way to do that. So like, again, we use these patterns we saw. Pattern is that like this plus this is always equal to n, which in this case was 11. And then we saw that we remembered that this number, 7, was always the same as that number, which helped us get this coefficient. So if you keep using those patterns, it's going to make your life a lot easier with these. And this one is the same. It asks the question, instead of just asking for the coefficient, it asks for the whole term. I guess technically, if I go back here, I should say, the answer to this question is this number, right? The x to the 4th is not part of the coefficient. So this next problem is asking for the whole thing, asking for the whole term. And again, when the numbers are big, like 15, I don't want to have to expand it. Just when n is 15, that's way too big. So I'm just going to use the patterns that I know in the binomial theorem to figure out what this term is and then just use it. So the 7th term. So it's going to be 15 choose something. And I know that for the first term, the something is 0. And so for the second term, the something is 1. And for the third term, the something is 2, and so on and so forth. But for the 7th term, the something is going to be 6. And once I know this number, I'm good to go. I'm going to have a power, and this power, this 6, is always the same as this number. So I can put a 6 here. And then I know that whatever the first power is, when I add it to 6, I have to get 15 every time. So it's got to be a 9. And now I'm home. I just got to put my numbers in, 7x, 2y, and then just calculate all these numbers. 15 choose 6 is going to be a pretty large number, I would guess. And it is 5,005. 7 to the 9th is a very large number. I'm not even going to write it down. It's just too big. 2 to the 6th is 64. If I try and do 7 to the 9th times 5005 times 64, I get a number that's so big. Oops. Sorry, it's x to the 9th and y to the 6th. I can I raise this as 7 to the 9th times x to the 9th. I put these two over here. When I multiply all this out in my calculator, I get a ridiculously big number, which is 1.2926-ish times 10 to the 13th, x to the 9th, y to the 6th. So this is the 7th term. It's super ridiculously big, but there's no reason you can't do this. There's no reason that this work should be difficult, particularly if you get to use a calculator. So the practice for this is some problems from a textbook I provided. There's answers on the second page. So this is the kind of stuff you should be expecting on your test.